Problem number 31. They give us a function and ask us to find its second derivative with respect to x. They tell us that a is a constant, so a squared is a constant also. And this problem is going to start out like many of the practice problems we've done throughout the year, but it's going to have a different little twist at the end. So hang on and watch this little algebra trick that comes into play. Okay, to differentiate, let's go one term at a time. The derivative of x squared with respect to x is 2x. Derivative of y squared with respect to x is 2y dy dx. The derivative of any constant is 0. So now we're going to get dy dx by itself. So we're going to go minus 2x, subtract 2x, and we'll divide by 2y. You notice that the 2's eliminate each other. So we can say dy dx equals the opposite of x over y. Okay? All right. Now, second derivative of y with respect to x require the use of the chain rule. Not chain rule, I'm sorry, quotient rule. I misspoke. So we're going to go low d high, minus high d low, all over low squared, and go must things go. So let's clean this up a little bit, and we're going to get second derivative of y with respect to x. So it makes you negative 1 times y, the opposite of y, minus the opposite of x plus x times, now, wait a minute, dy dx, we found earlier that dy dx is the opposite of x over y. So we're going to put here, all over y squared. So now we found the second derivative, only this is a multiple choice problem, and we have to make our answer match one of the ones listed. Well, we've talked about this many times before. We don't like to leave our answer with a complex fraction, so we have a fraction inside of a fraction. Let's do something about that. You can think of y squared in the denominator as y squared over 1. And remember that dividing by a fraction is the same as multiplying by its reciprocal. So we're going to think of this as times y squared, 1 over y squared. So instead of dividing by a fraction, we're multiplying by its reciprocal to multiply this whole quantity. Now watch what happens here. Something's about to happen. Second derivative of y with respect to x is going to be the opposite of y over y squared. And plus x times the opposite of x is going to be minus x squared. And over y times y squared is y cubed. Okay, we're close. This still doesn't match any of the options. So let's get a common denominator and see if that helps. Let's multiply this first fraction by y over y, because multiplying by y over y is really multiplying by 1. Multiplying by 1 won't change any values. We're just going to make our answer look different, have a different form. So we're going to get the opposite of y squared over y cubed minus x squared over y cubed. And we have a common denominator, so we can put this together in one fraction. The opposite of y squared minus x squared over y cubed. Now if you look, this still doesn't match any of the answers, and this is where the trick comes in. Right here. Remember what they said in the beginning. Our function is x squared plus y squared equals a squared. So we're going to use that information right now. X squared plus y squared equals a squared. So if you multiply by negative 1, you're going to get the opposite of x squared minus y squared equals negative 1 times a squared. Here's the trick we got to think of. So here we go. We can replace the numerator with the opposite of a squared and then over y cubed. This is our answer, and this matches one of the options. Now, which option was it? Let's take a look. Option D. That's a sneaky little trick there. But you've seen it now, you'd be more likely to catch this in the future when you're going through a problem for the first time on your own. Hey, thanks a lot for watching the video, guys. Hopefully it was helpful. Good luck on the rest of your work.